Hi everyone, welcome to Tom's Manshed. Okay, and welcome to part 2 of the printing and the assembly of the spool rewinder that I showed you in part 1. Now hopefully you've seen part 1 or this won't make much sense, so check out that one first by this link up here and the tile at the end of this video. And in part 1 I waffled on for ages at the beginning, explaining what this gizmo that we're making is for, and printing all the parts off and laying them out in Bambu Lab's studio slicer, and what to print them with, and so on and so on. So we've now got ourselves a kit of parts to assemble this machine. So first of all, I'm going to show you shortly all the bits I bought off Amazon. And usually when I'm showing the Amazon pages, I sort of like to show you some comparison ones and different choices. Well, there are so many parts and this video is going to be so long that I'm just going to fly through them a bit quicker than I normally do. So I'll show you that in a minute. And I'll also list every single part, every nut and bolt, and if I had to buy any tools, which tools, heat inserts, stuff like that. I'm going to list them underneath in the description. They will be Amazon affiliate links, which means if you do click on them and you buy anything at all from that browsing session, I get a slight commission, just a few pennies. It doesn't cost you a penny extra than normal, but it helps keep this channel going, so that'd be great. If you're going to buy anything from Amazon, click on one of them links first. So like I said, that will be in the description. And again, as I've just mentioned, this video is going to be extremely long. I anticipate this is going to be over an hour. I had to slim the other one down to 50 minutes. This is probably going to be over an hour. So as always, I'm going to put the red stripe underneath, and all the sections of this video will be itemized and annotated, so you can scroll along and see which bit you want to see, which bit you want to skip. You might want to go straight to the end and have a look at the thing in action. So before we get with the actual screwing together of all the bits, let's have a look now on Amazon at all the parts I bought. Okay, so in no particular order, these are all the parts that I bought for this project. This was the motor, and that's the exact motor for it. It's got the screw spacing, the flat on the shaft, 500 revs, really nice. 16 quid, not cheap, but seems well built. Next thing was a speed controller. This was a pack of 2. I think one wasn't much cheaper. I think it was only like a couple of quid cheaper for one. So I thought I'd buy 2, thinking may fit another one in another project in the future, but more likely it'll just stay in the drawer forever. The inserts, the little inserts there. Again, there's loads of different sorts of these, different threads and everything. I just got the M3, 4 and 5 ones. You'll only use the M3 ones on this project, but I've got them in. Now the heat set insert tips, these are the ones I got. Now I wanted these with the thread there, because that screws straight in, as you'll see later, into the tip of my soldering iron. But there are different ones of that with a female thread there, and that might be more suitable for your soldering iron. So make sure you get the ones that fit your type of soldering iron. Showing you they will fit there with that adapter, I think. But on mine, like I said, that threaded bit, it's an M3 thread, and it screws directly into the end of my soldering iron. The bearings, dead cheap. 20 pieces for £6.18. So it's not worth printing the plastic ones on your 3D printer. You might as well put some proper steel ones in for that price. So they're the ones I got, various colours. I've still got quite a few left over from that. The other bearings, the ones that support the spindles that go through the spools, they're a bigger one. 30mm outside diameter, but again pretty cheap, £11.50 for 12 of them, and still plenty of them left. The screws, I only wanted one of these but didn't have any. I did want a countersunk M5 30mm long one, but that dead cheap pack of 50 for yeah, there you go, at the top, £2.70 for 50 delivered. Did take it wasn't next day, took a couple of days to come, but still pretty good. And again, here's some of the screws I used, and these as well. These may be more suitable because as you'll see when I'm putting them in, the plastic heads, they've got a fatter head that fits better in the plastic. And finally, the filament I got, that Tin Mori. It's really, really nice. It says Tin Mori upgraded PETG Eco, so I'm not really sure what it means. You can read that bit there. It can print 3 to 5 times faster at speed of 300mm than other brand PETG. Well, I can confirm it printed absolutely beautifully, and I got it. It's $14.98 now, but I got it, as you see there, for $11.95 for the black, $12.73 for the white. So keep your eye on prices for that. As everything on Amazon, they do zoom up and down regularly day to day, but yeah, under 12 quid, and it printed very, very nicely. Okay, so I thought I'd just throw that bit on the filament in at the end. Obviously, just use the filament of your choice, but I can confirm that Kilmori one does work very, very nicely with the Bambu printer. So we'll start on the assembly now, and throughout the assembly, whenever it's relevant, I will be putting up here wherever, a little diagram of the animated assembly procedure from the Printables website, from Niklos or Diplomator, the original assembly instructions in an animated diagram, but there are a couple of discrepancies that I've come across. So where there is a discrepancy, I'll point it out. And we'll start off with the first of those slight discrepancies with the long shaft, the main shaft that goes through at the front. So let's start with that now. So this is the animation that accompanies all the files on the Printables site, and it's very, very useful to see how all the bits go together. But there are one or two discrepancies, the first of which is the shaft there on the left, the main shaft. You'll see a third of the way in or so from the left hand side, there's a little blip, a little sort of like raised nipple. That is to go in the worm gear, but it shows it, as you'll see shortly in the animation, pushing that shaft through the bearing. They put the bearing in first and then shove the shaft right through it. But the trouble is the shaft will not fit through the bearing because of that raised nipple. So you've got to push it through the hole first and then put the bearing on after, as I'll show you shortly. There you see the bearing is going in first, and then the other bearing there, and the next bearing. Then the worm gear will go down ready for the shaft to go through. But it's here, pushing it through. You can see it going through the bearing now. Well, it won't. In real life, it won't go through the bearing. But the rest of the animation is fine. That's how, but I'll show you actually how I fitted it. From the outside, pushing it through, it's a very tight fit in the bearing. And as you get to that, I've marked it with a bit of black marker. There's a little blip on the shaft that goes in a little groove in the worm drive, and as you push it along, of course, it catches on the bearing, so there is no way you can push it from the outside of the framework through that bearing because of that little thing. So what you have to do, you have to take the bearing out of that side. So once that bearing is removed from there, you can put the whole shaft, including that lug, through. So start with the lug on the outside, push it through, get your worm gear ready, and again I've marked the uppermost bit where that bit is, so put that over your shaft, we can then push that through that bearing there and through the outside bearing. That worm gear then shoves along and see, made a mistake. See, I've not lined them up properly. So take that out. And it's there, you can see. So shove the shaft through both bearings again, and this time, because we've got the two black bits lined up, we should, as we shove this worm gear along, it should go over there. We can feel it go up against there. Shove that shaft through there. So we've got some sticking out there. And now we can fit the bearing over there. But like I say, without that, there's no way we would have shoved that. If that bearing was in place, like on that diagram, there's no way we would have shoved that through. So that's through there. It's flush with that bearing. That is pushed back, clicked in there. I'm hoping it will stay in there over that lug. If not, you could just put a bit of super glue on there or something just to keep it in place. And then on this side, we've just got, as it shows here, again, I'll bring up the diagram again. It shows that, and that's a 3mm spacer. Make sure you put the 3mm, because there are a couple of 2mm ones in there and a 4mm one. So you put one of the 3mm spacers on there, and then this one, which is the 25 gear teeth from the drivetrain plate, that goes over there. And as it shows on the video, we put the teeth, the herringbone teeth, to the back of the unit. So the arrows on there are facing to the back, and that just clips on there. Again, nothing at all to stop that coming off, but once that cog is in there and trapped in there, I don't think that's going to go anywhere. But if you wanted, I suppose you could put a bit of glue there. So that's the bottom bit done now. So let's go on to the next bit. Now it's this next bit that, again, I was having a bit of trouble with. I couldn't figure out doing it as per this exploded diagram. It just wasn't fitting. So as you can see on the diagram here, as we run it along, you can see the shaft going through the bearing there, or the hole. So the bottom bearing goes on, and then before you drop the top bearing in, you drop the 4mm spacer in. That's that 4.1mm spacer. Again, don't know why they couldn't have just made the hole around here just tight enough for the bearing. There's no need for that spacer then. So that's already done. I've got that in. So bearing underneath, 4mm spacer under this red bearing. Take it off to show you what I mean. Under the red bearing, and the shaft through. Then shows you a little 2mm ring going over. So there we are. Then the cogwheel. So we'll just stop it there. Then the cogwheel. And what that 2mm bit does is raise this so it's bang on the middle of the worm drive. So you can see that is bang in line with the shaft now. So that's right. Now it's this next bit that I think is wrong, or there's something wrong somewhere. Because it shows another 2mm spacer going on. So we've got the gear over there. If we put that 2mm spacer there, and then the bearing, which is in there ready, in that slide bit. Mine's white on the diagram there, it's black. So if we carry on with the animation, space, that bearing, like I said, that bearing is already in the bottom of my thing now, and then them down. If I put that on there now, that is not going down far enough. You can see there's a big gap here. It will not go down so that the bottom of it is touching the orange thing like it should be. It shouldn't be in mid-air like that. It's supposed to go right the way down. And then it shows you slide going on like that. And then this gear. Again, you're going to have to line that up with these bits to get the right movement. And then you put a threaded brass insert in the end of the shaft there. And a screw, and that will go in there. But like I say, you can see a huge gap there. So the only way to make that sit down snug, as it should do, is to take that spacer out. And that goes on there now. And that goes in there. And as you can see, that is a nice snug fit down. And it's free to slide. And that's how it should be. So that spacer there, that top one, that top 2mm spacer, should be there in my opinion. And that's how it looks. So you can see the bottom one is necessary to bring the cog up in line with the worm drive. But the top one, when the spacer is in, it raises this bit up too high, so the sides don't touch the bottom there. So my advice is leave that spacer out, and like I say, tell me if I'm doing something wrong. So I'm going to get that brass insert put in there. Like I said, I've never done them before, so I'm going to have a practice on some other bits first. Line up this cog properly, I'll go through that as well. I've had a bit of a dry run. It seems to sort of catch on the, as it comes to the side, the teeth go around. I'm hoping with a bit of movement they'll bed themselves in, I don't know. But anything that I need to point out I will do. But we'll get that on. And that's as far as we've got, and then we'll carry on with the rest of the cogs. So yeah, I'm just squeezing this bit in. Any continuity spotters will spot between bits of this video, my hair's cut and not cut. So this is filmed at a later date. But I just thought I'd add this because, as I showed you that diagram then with the white slider bit down, you could see that the bearing housing on it was splayed a bit. It got sort of warped a bit in printing. And I thought, well, maybe it's that's holding it too high. So, you know, I printed another one in black. You can see there the bottom of that is pretty flat. So I tried that and it made no difference. So it's not that angle of that spacer. I just found it worked best without a spacer. So I don't know. Maybe it's something I've done wrong, but that's how I found it. And also, during the video, you'll see in the next bit, the actual sliding mechanism, mainly orange. I even tried, when I was getting it to moving it and it was catching, and the reason being I was turning it the wrong way. I thought I may have printed it wrong, so I tried it in PETG, I tried it in a PLA, I even printed some different gear wheels, but no, it was because I was trying to turn it the wrong way. If you investigate further, somewhere online I found from Miklos a video, and he points out that this gear here, you can see it's like angled to clear the cogwheel. You may sometimes find if it's catching slightly on there, You may have to file it off a bit. It's either that tooth or this tooth, but it's in his video somewhere online. I'll put a link to it below if I find it again. And you might just have to, depending on how accurate your printer is, just file a bit off there for it to clear. But I didn't. It printed beautifully and there was no discrepancies in them cogs. It was because I was trying to wind it the wrong way. So, right, let's get back into it now and carry on with the construction. Okay, so it's a while after I recorded that bit now. So about a week later with doing this, that and the other. And did have a couple of problems, and worth pointing out. This sliding mechanism, as you saw there when you were just watching it, this was printed in white. Now, as it moves round, this moves backwards and forwards because that is bolted on the top of it later, the guide. And that's what feeds it onto your spool properly. Now, it is very important that you line this gear wheel up here with the teeth in this bit here. Now, the best way to do it is get that slide bang in the middle before you push any of the assembly through the drive cog underneath. Get it bang in the middle. And that's how it should be. You might want to count along the teeth, take a picture of that or whatever. But you can see the two end teeth are roughly sort of like level with the bar, but that's the position it should be. If you look here on this diagram from the exploded animated diagram, you can see there the wheel, that cogwheel, is orientated completely wrong. It's about 90 degrees out of whack. So that's not how you put it. That is how you put it. Now, once you've done that, you can see I've got the threaded brass inserts in. I had a practice on some scrap stuff and it's dead easy. I'm going to show you me doing one later on. The first one I did, which was up here, and after my practice, and it went absolutely straightforward. So I'll show you me actually doing one and the parts I got and how to do it after this. Like I said, dead easy. All you need is a soldering iron and the right parts. But once you've got that in there, that place there, and like I said, that spacer is not there. The only way to get this white bit to bed right down onto that platform is to leave that top spacer out. So you do that, you put the brass insert in under here, these little, I think they call them lock nuts, they're just more like domed washers really, that you put the screw in. Now that stops it all flying apart, but one thing that wasn't in here, and it doesn't mention it at all, again, if you look on this exploded diagram, from beginning to end of putting this slider mechanism on, you'll see there is no bolt going underneath through there. And if you don't do that, what can happen is that whole top bit can just come out on the shaft like that. Now, how it'd be in real life when it's sliding backwards and forwards, I don't know, but I don't like the idea that it's pretty easily removable. The shaft isn't a particularly tight fit through that bearing, and even if it was, eventually it might loosen up. So I did not like the way that could happen. So what I did was, there is a hole ready for an insert in the bottom of this shaft already, so I don't know why it doesn't show this, but what I did was put another one in there and put another screw and whatever they call that thing, retaining washer or whatever, through the bottom. Make sure the shaft is exactly flush. You might find a tiny bit, 1/16 of an inch, millimetre or so, sticking out. If you don't put that in, it will have a bit of play. So get that exactly flush with the bearing, and then once the screw is in, that white washer thing is flush with the bearing as well, and that means it cannot pull out. So that is secured in there solid. Now, another thing I came across was, the reason this is now orange was the white one was perfectly okay, but I was sort of trying it for movement by moving this cog by hand, and I was moving it the wrong way. If you wind it backwards, I'll wind it forwards first to show you. Obviously it goes much faster with the motor, but as it's going round, it's a very clever mechanism. As it's going round, the bottom teeth come to the end, and you can see there's some differences in the teeth. There's like a dip and one higher. As that tooth is coming up to the top one now, it's missing that gap, see? And then it engages that one, and then it carries on round, and it's very smooth. And again, it comes to the end. I'll just whiz it round quickly. Best doing it with these gears here. As it comes to the other side. Again, it pushes out that. The bottom one misses that thing and then hits that, and it's nice and smooth. There's no skipping or nothing. But if you'd go backwards, I don't want to go backwards because it doesn't like it. As you go backwards, because them teeth aren't lined up, when you get to this sort of the edge, it clunks, and it's a horrible thing to think, oh, it's going to start wearing teeth out or breaking something. So if you're trying it manually beforehand and you're getting skips, make sure you go in the right way. But like I say, if you get it in the middle, get that slidey bit in the middle so there's an equal amount of white bit sticking out each side, and then line your teeth. You can see both both these end teeth here and here are just sort of like sitting on the bottom line of this slidey bit here. So that's how you line them up. And then once you've got that on, you just screw this bit to it there. That's your guide. I'll just screw that on now. So you can see now the filament guide is on there. Again, there are two brass inserts in this. The reason being, once you've shoved your PTFE tube through, you just tighten these screws down onto the tube and it just grips it in place. Obviously not too tight or you will squeeze into it and the filament won't go through, but just enough to hold it in place. And you can just adjust the length either way, and you've got these sliding bits you can move, so you can get that exactly in the position you want from left to right. And now that whole mechanism, as I showed you before, is going nowhere. That can't come up because of that screw underneath, and that can't come down. Obviously, when I screw it to the plank of wood that will house everything at the end, the shelf or whatever, that bit is going to be proud. So I'm going to have to drill a clearance hole in the wood for that to sit in, but that's an out of a job. But it won't go flat on a table with that, but I can't see any other way of anchoring that shaft in. You can't glue it into a bearing. So that's the only way. So that is all that. That's about the hardest bit, setting all that lot up. But like I say, it runs really smooth, and it's dead clever the way that mechanism works. So right, let's get on and just do these two cogs. These are just straightforward. It's exactly as it shows on the exploded diagram, which I'll show you. Okay, so 2 or 3 days later, I've had my hair cut, and the stage we just left it at was all this sliding mechanism. So we're going to put these two cogs in now. I showed it working with them two cogs in place, but I'm going to show you actually fitting it, because I said I'll show you every single bit. This is a dead easy bit. It's exactly as per the diagram. You may have noticed there's a black cap on this screw but not on any of the others. I'm going to go into that later. These black caps aren't strictly necessary, but if you do want to do them, you're going to have to like heat up the screw with a blow lamp or whatever and shove it into it. I'll show you that later on. I'm also going to show you later on the fitting of these brass heat inserts. I filmed that. I'm going to put that at the end of the video. You may remember I showed you the tips for your soldering iron and the brass inserts from Amazon earlier on. I'll show you actually installing them at the end of this video. So, like I say, this is where we're up to now. We've got this bit there, and that's the direction it goes, in the direction of the arrows. Now, these two cogs here, they're both the same one. I think it's called the 52 gear. I'm not too sure. But these go there, the same one. You print two of them, and they go there. I'll put the diagram up here again, the animated diagram. The only discrepancy in that, all the washers are exactly the same how it goes. The only discrepancy is it shows that is how the cog goes with the teeth facing forward. It's the only way it'll go. It's the only way they'll mesh in. These herringbone teeth, if you try and put them together the same way, they won't go. The only way they will mesh is like opposite to the one below it. So they actually go they're facing in the forward direction, as you can see on the diagram above. They're facing in the backwards position, but that doesn't really matter. So through there, it's hard to hold everything one-handed, but I found the easiest way was to put the shaft, because you've got the shaft, that little washer, one of them spacers on the printer, goes on between like the orange bit here, the bearing holder, and the cog. So what I did was put it over the bearing already, start shoving that bearing through. So start shoving the shaft through. So we've got it through that outer bearing now. And then get your other washer spacer, drop it over there like that, and then put the other bearing in. So yeah, I just had to put it on my knee to do it. It's hard when you're holding it to the camera. You won't have that problem, obviously. So yeah, you can see it there. You've got your, don't know if you can see, the cog, then a little white spacer, then the bearing, and the shaft goes through. Now, again, the brass inserts I've already put in here, and once you've got them in, you screw a little 3mm screw. Sorry, so yeah, an M3 3mm screw, and one of them, what they call locking rings, which, like I say, is just like a dished washer that holds the screw, and you put one of them at both ends. Now, one thing worth noting is I found the shaft a midge, only about 1mm too long, because if it sticks out there, if it comes further out, you'll find that washer just makes contact with the end of the shaft, and there's still a bit of play. What you want is that shaft to finish exactly flush with the bearing. So what I did was I melted the insert a bit deeper than normal, leaving some plastic around it, and then I just sliced it off absolutely flush level with a sharp Stanley knife. And then two washers now, this one and this one, are right butt jointed up to the bearing. There's no play, and that makes that fit really, really well. So I'll do the top one. It's exactly the same order, washers and everything. So okay, so that's it all on now. You can see the direction the teeth go. The bottom one and the top one the opposite, and then that one the same as the bottom. It's the only way they'll go, and there's no play in them now with them spacers, and like I said, they're cut the ends of the shaft exactly flush with the bearing. So that's that bit done. You can then put these things, these are purely cosmetic, but it does look better with them on. So you can click them over there, little covers. And I mean, you can still see the bearing here. You can still see the one on the green one there on the inside. There's no covers for them, but yeah, if you just want to add them, it makes it look good. So that is most of it done. Okay, so we're now ready to put the spool holder on. Now, you may remember when we printed it, these are the parts for the spool holder. And I'll show you this one first of all. This, you put 3 bearings on it. I've got this screwed in tight now, and it is a very sort of tight fit screw. But that's the little sort of like the top hat shaped thing there. That goes in there, and then you put the 3 bigger bearings. These are not the same size as the bearings in this. They are bigger, designed to fit in that cutout there. And again, I showed you at the beginning the ones from Amazon for them. So that's that side. That's the side that goes with the gears. And these two, you may remember when we printed them, one is shorter than the other. The reason being is this: if we, obviously the spool that goes this side, the part where we're doing, is going to be 99% of the time the Bambu Labs spool. And if we try the shorter version of these, this one, on that, where is it? So it's right next to me, couldn't see for looking. So if we get the shorter version of these, and we try and screw it into this, and don't forget it's a left-hand thread. So position the filament so it's on the bottom, and make sure that's the way round it will be orientated in the frame. So we want the triple bearing away from the gear, so there, and this then screws through the spool into that. But as you can see, this short one, it's hardly it doesn't really reach the threads. It goes about a quarter of a thread, then comes out because it's too short. This reel is too wide for it, so we need the longer one of them. And like I said, left hand thread, so you tighten that in there like that, just tighten it up, and then that drops in the frame like that, and the cog, make sure it's meshed up. And as you can see, the reel is bang in the middle of the frame, and we've got, it's like sitting on the middle bearing there. And again, if we move it here, it's a really smooth. When that is on, you take 2 top support bracket things, holder inners, and if you look on here, we remember when we printed them, if you look at the difference between these two, you'll see this one here has a cutout in it, and it's got like an extra chamfer there. The other side, they look pretty much the same, but again the chamfer is more. But this one with that bit there, that indented bit, that goes on the gear side here, and it's to clear this cog, so that goes like that, and you can see that, where are we? That cut out there is to clear this gear. So then screw that down on there, and the one the other side, just goes over like that, and that stops it jiggling out. Now, if we want to fit a different spool, so say we were winding it onto a spool like this, which I wouldn't do because it's much different than the Bambu Labs one. You can see it's a smaller diameter, but the main thing, it's got a huge hole in the middle compared to the Bambu Labs one. And it's for this one that we need the shorter of these two. So if you try it with the longer one, it doesn't tighten it up enough, it jiggles around. So again, put that in there. And screw that on there. Left hand thread, remember. And they sit, this time they sit right in there. And then if we drop it in place in the frame again, the only problem this time, okay, that's in the frame now, and as you can see, it's to one side, it's not in the middle. It'd have to go over a lot further than that side in the middle, so we'd need a different type of adapter here, which we haven't got for this particular reel. You would alter this here, backwards and forwards, so that the left and right corresponded with it there. But the main problem with this is, as you can see, that it's only just sitting there on that bearing. It's only just going in front, and it's dead easy to come out. Really, it could do with coming out a bit further. So what I'm going to do is put some washers in there. I've got some copper washers which will space them bearings out, and that will then make that bearing fit better. So I'll just do that and show you what I mean. So while I fit these washers, that's I've obviously had to take it apart. So that, as you can see, is the top hat bit that I was on about, with the M5 screw going down there. That isn't like a clearance fit. It doesn't need to be sort of threaded or tight in there because it's screwing into this bit. But it's very, very tight to screw you through there. You may want to run a drill through just to make it a bit easier, or put WD like I did on it. This bit obviously has to be tight, and it is. I don't think it's threaded, I think it cuts its own thread. But remember, it's an M5 bolt in this side. So what I'm going to do is just put 3, I think should do it, 3 washers in there. And then I should just space it out that bit. Tighten this down. Obviously, you know, reasonably tight, but not too tight to strip the thread in the plastic. Like I say, I use PETG, which is probably a bit tougher, but don't raunch it because it is just a plastic thread in there. So when we put this in the reel now, it should line up. Let's have a look at that. So as you can see now, that is much better in there. I could probably fit one more actually. I think I will just fit one more. So yeah, now you can see, oops, get the cog in. You can see it's totally in line with the bearing now. There's no chance of that popping out even with bending the frame like that. So, and of course it will still fit with the Bambu Labs one. So like I say, there's the Bambu Labs one in, and you can still see it's lined up with the bearing. There's no chance of that coming out, and that's bang in the middle. Now, one thing to remember, again, which a slight mistake I think on the part of the animated diagram, again I'll put it up here to show you. This side is correct, it's an M5 bolt. M5 by 30. I don't think it's 30. Yeah, that's the bag, mate. M5 that I showed you on Amazon. M5 by 30 mil is what you'll need to screw into that. But this side, it also says M5, and it's not. This is for an M4 bolt. So it's a countersunk hole in there. I didn't have any countersunk M4 bolts. I only had Allen key ones or Phillips posi drive type ones. So I used one of them. As long as it's screwed on reasonably tight to get it. Like I say, you don't want that slipping. But again, when you're screwing it in, even more so because it's a thinner hole, don't raunch it round and strip the thread in there. But it is M4, not M5, as it shows up here. So bear that in mind. And again, once you've got them in, you just drop that in, line up cogs, and that spins round beautifully. Yeah. There's like no friction, it's really smooth movement. And then we've just got to screw these two bits on top. And again, you can just use normal screws, you don't have to have them black head things on. But I am going to put them on, particularly for this, because this is something that will need to come on and off every time you put a new spool on. So it's a lot easier doing it with the knurled black bits, like on here. So we're nearly there, we're getting there. But before I show you the motor, constructing the motor and the donor spool holder, I've just mentioned about the black caps for the screws, so I'll show you what I did. Now I've got some sort of silver M3 screws, and I got some black ones as well. The difference being the black ones have got a broader head, you can see there, and there are like little tiny grooves around that head, so if you could sort of like knock that into something, it would grip on them grooves. Now that is, I think it's 8mm long, and these are tiny ones, 3 or 4mm long. You'll find that these tiny ones are enough. That's all you need. You only need that thread, that much thread in to most of the things on here, apart from a couple of things that I'll point out which need the longer one. Now, to get them in the hole there, it isn't quite big enough to get it to squeeze in there, the hole. Now, I tried squeezing them in with a vise. I put a little 3mm nut on the end of there, and I trapped that in a vise, and it didn't have the power to go in. I thought of taking it outside and putting that face down on the concrete and hammering that in with hammering the nut to try and not damage the threads, but it's only a tiny bore screw, and any sort of hammering is probably going to damage the threads. So I thought I'll heat it up with a blow lamp and shove it in, and it works brilliantly that way. So I'm just going to show you that now, and I'll show you on the little tiny one first. So yeah, I've motored the camera down so you can actually see me. So what I'm going to use is this little, any blow lamp will do. I did a review on this, again, click above, I'll put a little tile in that. I picked it up 2-3 years ago from Aldi. Nice little kit. That's the main thing I use. I don't use it for soldering. I use a proper soldering iron for that. But this has come in extremely handy. And as you can see, it's a nice little lamp. You can see that there. You can lock it in place. So all I did was put it there over my bridge, get a little pair of pliers. And like I say, I'm using the little tiny screw smallest of them all. And you only need to heat this up just for a few seconds. Don't get it too hot. Don't get it red hot or it'll go really melt the plastic. So you'll see how long you take to do it. I'll sort of show you doing it live. You'll find that is long enough. So I'm trying to, and then as I push that in there, you can see it's not quite straight. So while it's still molten, you can get that pretty straight. Turn my blow lamp off. Okay, so that's off. So you can see that there, it's gone sort of slightly lower than the surface, and any of that swarf that's sticking out, that melted remnants, you can just see it creating like a little bit of a lip there. You can carve that off with a sharp knife. But once it's set, that is solid in there, and just that bit sticking out is ample for nearly everything on the thing. And as you see, I've got everything now covered in them caps. If you've put your inserts a bit too deep, you might have to do that heat thing on the slightly longer of the screws. But if you use that, that is too long. What you're after for is you want in the black face to actually act as a load spreader, like a washer. On this one, I've used the longer ones on these because the idea of that is it's to grip the tube underneath. The tube is quite far down, so you don't need that to touch the top of this. So I put longer ones in for that. And also, I think I did for that because you've got to account for the thickness of this bit here. You can see they're not at an exact angle, and that bit of sort of melted swarf underneath is acting as a wash, but they're doing the job. And the top ones there, they hold down, so they're solid, and it looks a bit better. And when you swap in spools, it's a lot easier to undo one of them than having to get your screwdriver out. So that's the way I did them. While we're at it, let's have a look now at how I did the brass inserts. Like I said, I'd never used brass inserts before, so I'll quickly show you that now, and I'll show you the soldering iron I used, and I'll put a link above for that as well. Again, I don't use this soldering iron now, I use my pine sill, and I won't put a link in for that. Just do a search for the pine sill one. I did a review on that, great soldering iron. But this old Lidl's one is ideal, as you'll see, for putting these heat inserts in. So let's have a look at that now. So apologies for any printer noise in the background. I'm printing something else at the moment. But this is the soldering sort of station I'll be using. Check the link above for the review on this. It's quite a while ago, and Lidl's have got different ones now. But I've stopped using this since I moved to my pine sill, which is much better at soldering, but this has turned out exactly what I wanted for doing these hot inserts. So if we turn it on, it's ideal because you can set the temperature with these up and down. You've got preset buttons here at 200, 300 and 400, and if I just sort of like say select the 200 first, and then you could go up to 220, 230, 240, 260. I've just been using 260. So you want something above the temperature that the plastic that you're inserting it into melts at, but not by too much. A normal non-temperature controlled soldering iron would work, but it's so much better if you've got something like this, and it'll get exactly right temperature. So again, it's not instant warm up like the pine sill. So it's up to temperature now. It took about a minute, maybe a minute and a quarter, something like that, to get up to 260, and that's it. Temperature's stabilised now at that, so it's not too hot, not too cool. So, and the tip
So it's absolutely ideal. That's the holder. Keep it in there between inserts.
So as you saw there, the insert tips I bought, that's the normal soldering tip you get. I got with it. Like I say, it's a couple of 2 or 3 years, whatever, probably now since I've had that. But ideally, that just unscrews, and the correct hot insert tip for M3 bolts screws straight in it. So these are the actual tips you get that I showed you from Amazon. That was a 3mm one that you just saw there in the soldering iron, but the one for M3 bolts, but that's obviously for bigger ones, and they vary. That's the biggest one. Don't think I'll be ever using anything that big. And it goes down to the tiniest one. That's for M2, I think. You can see there what they're for. M2 brackets M2.5, M3, M4, M5, M6, and up to M8. And the top sort of extension bit there. And like I say, I got the ones with the male threads to fit my soldering iron. So like I say, I showed you these where I got them from Amazon, the price before. Is the actual box. So you've got M3 times 3 times 4.2. It's just the depth and stuff like that, the different depths. And then the bottom lot are M4, and they really are tiny. That's the biggest one, biggest M4, deepest M4 one, and that's the most shallow. And it's easier to show you on the big one, but that is the end you insert into the hole. It's usually pre-drilled to accept that. So I'll show you with the M3 one. So that smooth bit without the things is the bit that goes in the hole, pre-drill hole, and it sort of like holds it in there, and you would then put your soldering thing into there, and you can see it's maximum contact and flat butt joins up against there, and just slowly press it in until that top surface is flush or just a tiny bit under the plastic. Sometimes it sort of springs up a bit after, but it's still being molten plastic, so you may be best sort of pushing it down a midges lower than the surface, and then it just springs back up. But yeah, they're dead easy. So let's have a look at me actually putting them in on the actual winder now. Okay, so I've got all the inserts in, done all these, but I thought I'd wait till the very last one to show you actually doing it on the thing we're making anyway. So we've just got this one to do in here. So I'm gonna pick a quite a deep one, because I've been using some of the smaller ones elsewhere. And hopefully, if everything has gone right, that hole should just accept the first bit and that support it. On this, it seems to be a bit, needs a hole drilling a bit, but on some of these other ones, on these here, it went straight in, no problem, but it's not actually sitting great. So you can see it's at an angle there now. It doesn't matter, once you've got the, whoops, see? So it fell off live. If you're holding it, hold it with a pair of pliers, because obviously your soldering iron is really hot. So that's it there now. And I've just got the iron set at 260 degrees. And I don't know whether you can see, I'm holding it up at an angle now. and that went too deep. It's because I was trying to show the camera it, so that's gone below the surface of the thing. But if you look at the other ones, so you'll have to excuse the scruffy attire and the unshavenness, but it was a last minute decision to film this bit, and you can see that bit I've just put in there, that is sunk deeper than ideal. That's because I was trying to hold it up to the camera and show you while I was doing it, and I wasn't watching it properly. But no matter, it's in there. The things will attach. I might have to use just a slightly longer screw than slightly longer bolt than normal. But you can see on the other one, that's nicely flush with the surface. Okay, so that's the heat inserts. Okay, so this is the motor section. Now, I mentioned right at the very beginning of this video, the way to orientate this when you're printing it is this side down. But the only overhang it leaves, or the only sort of horizontal bit, is this bit. Now, I didn't use any supports, as I mentioned. And I don't know, you can see inside there, you can see the strands hanging down, but that's all I got. I just pulled a few of them down. You're not going to see them inside. But the outside printed perfectly. So you won't need any supports in there if you print it with that face down. So that's the box in the design, and that's the plate and the cog that are in that file. Now, it's designed perfectly to fit this motor. Again, this motor is in the description. I'll give you the exact one I used. It's up to you to use any motor, but you've got to be careful to get the right motor shaft, the right shaft diameter with the flat on it for this printed cog, unless you can design your own cog with its own hole. And the 6 holes around it to screw it to this plate. Now, these are countersunk sockets in this printed part, but I didn't have any M3 countersunk bolts, so I just used normal pan-headed ones. So that securely held the motor in place. It's a nice hefty motor. I think it's about 16, 17 quid, so not cheap, but it's nice and hefty. It's got a gearbox on it. I used the one recommended in this file, which is 500 revs, I believe. And this is the circuit board as well. Again, shown in the link below, this exact circuit board, and this case is designed exactly for this, as you'll see in a minute. It fits perfectly. And this circuit board has, with it, I'm trying to hold everything up to the camera here, this switch, which plugs in there, like that. And it's a two-way switch. This is a reversing switch. Now, you won't need the reverse, or you shouldn't need the reverse function on this, because the bit that slides backwards and forwards, the shuttle or whatever it's called, if it starts going the wrong way, it doesn't like it. It skips a tooth at the end, like it's designed to go in with the gear underneath going in a certain direction. And I've determined which position on this switch sends the gear in the right direction. And seen from the front, you want it to be travelling in a clockwise direction. So again, you'll see that when it's on the complete item. So I've found out that when it is there, that position down, the 1 bar for the right direction. So I'm going to have that off in the middle and that at the bottom, because to me it's logical turning the switch on by flicking it down, not up. So yeah, you'll have to cut away some of the heat shrink, because the heat shrink goes right over that bit, and for that to fit in the slot you'll need to cut some away. So we'll put that in now, put the plug through there, shove that in there, and it is, you may have to use, no, I thought I might have to use, because I've not actually done this yet, but as you see, that fits absolutely perfectly in there. I thought I might have to use some pliers to squeeze together the grips, but no, that is solid there. And as you can see, I have soldered some wires to the motor, and on the back of the circuit board there you've got power positive and negative, and motor positive and negative. That knob pulls off and the screw, the nut comes undone before you push it in the box. Oops. And again, this case is made perfectly to hold this circuit board. Now, what I've used as an input is I just had these lying around. As I've mentioned right at the very beginning of this video, I wasn't sure what 12 volt source I could use. I think these circuit boards will take from 12 to 24 volts. I'm pretty sure I wouldn't have to buy one, and I didn't, because I found in a drawer this old transformer Roadstar. I think it was an old TV, a little tiny portable TV I had many years ago. But it's 12 volts. I know you can't see it there, but take my word for it. It's 12 volts, just 1 amp output, which is fine. That's all you'll need for this hefty transformer. And that'll go nicely, and the plug is an exact fit for that socket there. So I'm going to heat shrink this socket inside here. So I'll leave that there for now, but I'll show you how this circuit board goes. So you'll obviously connect that to the circuit board, and then it just slides in a slot there in the case, and the knob comes through exactly there. Like I say, everything is designed in this print around these components, so you may get some that'll do exactly the same job but might not quite fit. So, but the motor and this are linked below. The input I'm just going to leave to you. There is a hole there in the print for it. It's got like a flat, so there's probably some sort of socket that exactly fits that. I don't know, but I'm just rigging it up for what I've got. So the input is up to you, but the circuit board and the motor, that's how it goes. So I'm going to wire all them up now. So the motor just goes in there like that, and then it screws with these 2 screws. So I'm going to wire it all up there. Okay, that's it all together now. You can see the switch in there. I've just hot glued, like I said, that socket in. Everything's together, and when it's moving around, you want it to go, as you look at it from the front there, you want it to go clockwise. So you want it to go in the direction of the arrows, the teeth, the direction the teeth are pointing in. So if we plug that in, as well as the on-off switch here, like I say, which is reversing, so you'll only need it in that position. This is also a switch, and as you turn it on, so you get a red light as well. And if we turn it on now, and I'll turn this up, you can see quite a good speed control from, you can get it going from very slow right around to full speed. And like I say, it's a reversing switch. If you watch what way it goes now, going clockwise, and if I flick the switch the other way around, see, it's now going the opposite direction. So that's the one we want. And that is just pushed on. It's a very tight fit. There's no screw in the end, obviously, but it can't go anywhere because once that teeth is meshed up with the unit behind, it can't, and screwed down to the base, it can't go any forward. So we'll get it all mounted now on a plank. I think I've got a bit of old shelving, white Comty board shelving, which will be ideal in the garage. So we'll do that, and then I'll show you in action winding the spool. I've already tried it, sort of like a cold run behind, and it seemed to work fine, but get everything lined up and we'll show you the finished item. So that's the motor. Now that just leaves one part left before we screw it to the plank. We're really reaching near the end now for a marathon over an hour. So this is the sort of like unwinder part of the full assembly. It's half orange, half black, because I sort of run out of orange and then just carried on in black. Didn't really matter. But if you remember when we printed it, it only showed on the actual print thing just one of these parts, and I said you'd need two. Now, if it's a conventional sized reel, like a Bambu Labs one, it's unlikely you'll be winding it from a Bambu Lab one onto a Bambu Lab, but I'll show you how these mount with this, because there's other reels pretty similar. So, put one of the cone-shaped ones there, put this through there like that. That bit with the lip on is the bit that represents the bearing on the other, and obviously you put the other cone bit on there. Again, left hand thread, that goes in there, and that locks on like that with them two. And as you can see, it just goes in like that. There is a lip on that bit there, so it can't come out, and same on that bit there. So, like I say, it doesn't have to be high precision. This one isn't being guided backwards and forwards. It is in a way by the other, the motorised part, but bearings like that are ample for this one. So that's on a reel like that. And also, just to show you, these bits will fit on this type. It's quite unusual, this being that big, the centre bit, but again, that goes in there, goes there, and in this case they actually sit right in that indentation, but again, both fits perfectly. And again, it doesn't matter whether this is to one side or not, it doesn't have to be in the middle, that one. But this part, the wider one, the thing that's called whatever it was, plus 20 I think, that is for much thinner rolls like this. This is 1/4 of a kilogram roll. I got 4 of these dual colour ones. I love the dual colour stuff. This is the blue and yellow one. That's a Captain America done out of this colour. I just love the effect of the dual colour ones. And you can get like a sample set for the same price almost as a kilogram, 4 of these. But you can see how thin that is. And the normal, them two, wouldn't be enough. So in that case, you put one of the normal ones and the wider one. And then again, that screws in there. And that will go on there. So that's what that's for, and it can't come off that cable. It's got these 2 lugs on the end, so it doesn't matter which way around you put it. If you were dead keen to get it right in the middle of the frame, you could put them on from that way. I've just put this side instead of that, but well, that's that. So it's just now a matter of screwing both of these to an appropriate plank. Like I say, I've got some, I'm pretty sure I've got a piece of shelving, white Conti board shelving. Okay, so it's zoomed into the future now. Everything so far was filmed last year, 2023, just before Christmas. Got Christmas out of the way now, we're into the new year. It's the 4th of January, and I finally got it all done, as you can see. So I've got it screwed. I was going to do it to a bit of white shelving, but I found a bit of black Conti board. So as you can see, I've just cut that to size. Now, there is a recommended distance between these two. I saw it once on one of the many videos on Miklos's original site. Like I say, I'll put a link to the original files that the guy who originated the first sort of version of this, Miklos. And there's loads and loads of helpful videos on there on how to solve problems with this mechanism and so on. And it does recommend a distance between the two. I can't really find that distance. But if you do something like that, you don't want it too close. Don't put this as close as possible to that. Leave a bit of distance so you've got about that. And I found that worked fine there. So I've just, as you can see, I've just screwed it all to it. I've used number 10 sort of self-tapper panhead screws, 3/4 of an inch long for my purpose because I don't want them coming out the bottom. The hole, one thing that's worth noting is the clearance hole underneath here, to clear that bit I mentioned earlier on, the bottom of that shaft. I did that at first just 10mm diameter, which cleared that white washer. And when I put it all together, this was really stiff, and it must have been catching on the bearing. So make that hole if you're doing the same as me. Like I say, it might be something I missed in the files doing it, but to keep that shaft in there, as I explained earlier on, I've put that extra screw and cap on. So make sure there is quite a bit of clearance room around that to clear the bearing. But that's it, all done. That's the other side. See the controller. And right, let's see it in action. This was filmed the other day, and it just shows you it in action. So I've done it from 2 angles and used the best one to illustrate various stages. But when you're looking at it head on, sorry it's a bit out of focus. I don't know what went wrong with the camera focus there, but it's slightly skew-whiff, but you'll soon get the idea. I also speeded up a bit of it, so again, I put it on screen where I speeded it up by 5 times just to make it not long. But the whole thing took about 2.5–3 minutes, I would think, to do the whole spool. Okay, I've got the camera set up basically to film the process, so not too easy to see this, but I'm just inserting now. I've got the filament here. I'm just inserting it into one of the holes that I've pre-drilled in here. You can just about see it there. And I'm going to start it going really slow. So you best start in very slow. I've wound this back onto this reel here. I just tried it to practice it. So I've got it going pretty slow, but you can see the movement here, threading it reasonably central. Once we've got it going a bit, you can then speed it up a bit. Well, that's full blast now, right? So we'll leave it going like that, and I'll cut to near the end of it. In fact, I'll leave it going, I'll just speed up the video. So speed it up from here. Okay, we're getting near the end of it now, so I'm slowing it down. You're best slowing it down gradually. Just film this last bit in real time. So as we get to the end, they're sort of like guiding it. And that's it. So that's fully off the end, as you can see.
So it's now just a matter of manually winding it through, getting the end of it, shoving it through, taking the reel off.
So, as you saw, it worked really, really well. And that's the reel. I wound it off. Again, I showed you earlier on, but now it's off the machine. It's a bit easier to show you. But you see this side here is beveled down. So the only bit making contact with them rubber rollers in the AMS is that tiny, tiny ridge. This side is flat, but that side is beveled for some reason. So it's now off that. And it's onto the Bambu one I printed off their files, and you can see it's wounded on there pretty good. Not as good as a proper commercial when you get it, which is absolutely flat, but it's spread pretty much equidistant. It's humped a bit in the middle, but that'll come off there with no tangles. So yeah, it's worked absolutely fine. So, in conclusion, yeah, it seems to work pretty well. It's been a fun project to build. Like I say, I like building construction kits. If that's not your bag and you just prefer to buy things ready-made, this probably isn't the project for you. But yeah, I've enjoyed the building process, and hopefully it's helped you along if you're thinking of doing the same. The things to watch out for, the only things are, as mentioned before, the little spacer washer in underneath this mechanism here. If you are putting this bolt in the bottom, which is sort of my extra, it's not in the original thing, but I can't think of any other way of stopping it coming up, don't forget to put a bigger than you'd normally think clearance hole around there to clear the bearing. Other than that, everything was pretty straightforward to build. Would I make another? If I was to make another one, would it be a motorised one? Probably not. You don't need it motorised. I think the crank handle one would be ample. It's only going to be like every now and then. It's not going to be something in constant use. You're always going to be there when you're using it. They do for this motorised one. I've seen a version where there's like a run out, uses a run out sensor, which will kill the power once it's totally wound the filament off. But again, I'm never going to be doing this unattended. I'm going to be there and then slowing it down at the end and not keeping it full speed. So a crank handle would probably be fine. You'll save yourself a bit of money and a bit of work just doing that. But yeah, I'm glad I made the motorised one. It's quite nice to watch in action. So again, apologies that it has been so long. My style is to make long, involved videos, maybe too involved, and I know, but like I said, the red line is below. You can skip the unwanted bits. And as I always say, you can always skip a bit, but if I leave something out, it's left out, isn't it? So hopefully it's been okay. So coming up soon, keep promising, but I've filmed half of it, so it's in process. The reclining seat cover for my lazy boy behind, showing you which are good ones, which is a good one and which are two bad ones to get. That's coming up soon, and anything else that takes me fancy. So once again, thanks for putting up with the 50 minutes of part one and the hour and quarter of this, hour and 20 minutes, maybe an hour and a half, I don't know, of this. And I'm glad you've made it right to the very end, even if you have fast forwarded here. So if you have enjoyed it or it's been of some use, please give me a thumbs up. If you haven't, give me a thumbs down. If you haven't already subscribed and you'd like to, please click the little picture here of the shed. Once you've done that, click the bell icon underneath and you'll be alerted to any new uploads I do. And I hope to catch you for one of them uploads very, very soon. Thanks again for watching this one. Bye for now.